We've gotten rid of some extra white space in our graph. Now let's say maybe we would like to graph this a little bit differently in terms of the scaling of the axes. And that's really the next step to redefining our coordinate system. In R, the way the coordinate system is defined is what coordinate should align with each edge of this rectangular graphing area. In other words, this is the top, this is the right, this is the bottom, and this is the left. And in order to tell R what the coordinate system should be, you want to tell it which coordinates, which x coordinates are associated with the left and the right edges, and which y coordinates are associated with the bottom and the top edges. So let's go back to our R code. At this point, we're going to diverge from using plot. We're going to start calling our own functions instead of having plot call them for us. So I want to comment out this line of code. I'm going to leave it there for reference, but I'm going to comment it out so that it doesn't get in the way and we're not calling it anymore when we're creating our graph. So the first thing that plot does that we need to do is call plot.new. Plot.new, and we can look at a help on that. Is going to create a new plot frame. It's basically a function that will start a new plot. Now, what starting a new plot means depends on which device you're using. In the case of a PDF file, when you call plot.new, you're saying, I want to create a new plot, and what that does is it creates a new page in the PDF and gets you ready to start putting a plot on that page. So it creates a blank page. So we have plot.new to create our new page, and in order to set the coordinate system, we want to call plot.window. And the key arguments to plot.window are xlim and ylim. So I can do a help plot.window. These are also arguments to the plot function, because it passes them on to plot.window, and it's this xlim and ylim arguments. So my xlim are basically, or xlim is going to be a vector of two numbers specifying the limit of the x coordinates on the axes. So I can create a vector using the C function, and I'm going to have two elements, which are the left and the right extremes of the x-axis for the graphing area. So going back to the plot, that's where x is, where the leftmost coordinate is and where the rightmost coordinate is. By default, it uses the min and the max of the x values, which is going to be 0 and 60 in this case. That's our time, 0 minutes and 60 minutes. And notice there's a little bit of extra space. That's because by default, when you give an xlim to R's graphing functions, they will assume that you want to add a 4% buffer. So the value from 0 to 60, if you take 4% of 60, whatever that is, that's how much extra space there is between 0 and the left edge of the graphing area. Same thing with this. This is whatever 4% of 60 is. So let's just say that for this graph, we want to create some extra space around this. We want it to be maybe, give it an extra 5 minutes of extra buffer around these edges. So we say we want to go from -5 up until 65 as our xlim coordinates. We can do that by saying -5 and 65. So we're hard coding, we're saying it specifically, we want our limits to be -5 and 65. And let's say we want to do the same thing with ylim, where we're going to go from -5 to 55. So that is establishing our coordinate system. And I can rerun this code. And I can go back and lo and behold, it's blank. And that's because we're not using plot anymore. So now R is not making any assumptions at all. It's just doing what we're telling it to do. And in this case, all we've done is set up the coordinate system. We haven't actually graphed anything yet. So that means we can't see anything. Now, if we want to start seeing what's going on, we can start using functions like box that draws a box on a plot. So if I do a help on box, draw a box around a plot, I can say which area I want to draw the box around, and by default, which is plot, which stands for the plotting area or this graphing area that I've been talking about. So if I want to start graphing something, I can just call the box function, and by default, if I run that and I go back to my PDF viewer, now you can see where the edges of the graphing area are again. Top, right, bottom, and left, but there's nothing else because all I've done so far is draw that box. To see the results of our establishing a coordinate system, then we need to put some axes on this box so that we can start seeing how our coordinate system is laid out. So if I go back to R, after box, say I want to start drawing axes, and there's a function called axes. I think it starts with a capital letter. At least the one I want to use starts as a capital letter. And you see what we have some options for what we want to send in terms of arguments to axes. I can give it x values, and from those x values, it can figure out what the limits are. I can tell it where the side is. I can tell it what labels are. But really all it needs to know is this side argument. And the side is going to tell it which side I want to establish an axis on. So if I tell it side is equal, and these are the sides are numbered basically the same way you think about the edges, where the bottom is 1, the left is 2, the top is the top is 3, and the right side is 4. So if we want an axis on the bottom, we call side equals 1. And if we want an axis on the left, we call axis with side equal to 2. So if I run this code and I go back to the graph, again, R is going to make some assumptions, and it tries to make these look nice somehow. And I didn't tell it exactly where I wanted ticks on this axis. It just decided where to put them, right? And it put them at 0, 10, 20, 30, 40, 50, 60. So R made that assumption based on what the limits of the plot.window are that we called. So it made this assumption based on the coordinate system we've given this, because it doesn't have the data yet. We haven't told it anything about the data we're trying to plot yet. All we've told it is the x-lim and the y-lim. So now we have a little bit of extra space over here than we had before. Recall that 60 is our highest number, and we were only 4% above 60. Now we've told it, well, 65 is what we want to be here. And this buffer is now 4% of -5 to 65, because that's our x-lim. And we also have more space here because we said start at -5. So this is probably about where -5 is. And again, this is 4% of the distance between -5 and 65, the limits of our axis. Same idea with our y-axis. So that's our first step. We've established a coordinate system, and now we've started drawing enough of our plot so that we can see how that coordinate system works out. Now we can think about adding the data.